there are many different factors which affect whether enzymes are able to work at their optimum rate. And the first one we'll take a look at is temperature. So I've got a few graphs here which I'll use to try and illustrate the different effects of these things on enzyme activity. Right, let me label the graph first. So if we're looking at temperature and we have a scale, just extend it a little bit, at 50 degrees. In the human body, we have a temperature of around 37, 38 degrees. So what that means is enzymes are going to, or are made to function best at a temperature around that, because that's the environment that they're in. They need to be able to function well at that particular temperature. If we see temperatures getting too low, what's going to happen is there's not as much movement of enzymes and substrates around, which means that they're unable to collide as regularly in the correct orientation. If we see temperatures too high, what will happen is something called denaturing of an enzyme will occur. So the enzyme will denature because bonds start to break down, which hold it together and give its active site that optimum shape, so it's unable to do its job as effectively. We can see similar thing occurring with pH level. So if we have our pH scale here, I'll just leave it abbreviated like that. Enzymes will function optimally at different pHs. So for example, in the stomach of humans, we have enzymes that work well at really low pHs. So their optimum pH level will be quite acidic, whereas other enzymes in different parts of the body which have a more alkaline pH, we might see optimum pH level be more something up here like this. So once again, the pH level or an incorrect less optimum pH level can start to affect the bonding of the enzyme, which in turn is going to affect the shape of the active site, making it more difficult for the enzyme to bond to substrates. Moving on to our next one, enzyme concentration. So to a point, creating and adding more and more enzymes is going to see an increase in reaction rate, increase in reaction the enzyme is trying to influence. But we will see a point where eventually adding more and more enzymes is not going to have much of an effect on a further effect on the reaction rate, because basically we have too many enzymes and not enough substrates to go around. So all the enzymes, all the substrates that are present are being seen to by an enzyme. We have spare enzymes left over. So we see a tailing off in the rate of reaction. It will increase as we add enzymes to a point, but then we'll have too many enzymes that just aren't busy enough, so the reaction will start to equalize. A similar kind of thing will occur with substrate concentration. Once again, if there are more and more and more substrates being present, being maybe ingested by an organism, more and more substrates present until a particular point where we've got that many substrates that they outnumber the enzymes, and the enzymes are they're full, they're busy, they're all working. So the more and more substrates we add doesn't necessarily mean that it's going to lead to greater rate of reaction, because they're sitting around waiting for an enzyme to be able to see to them, break them down into products. The same thing can also be said for product concentration. We might see this equilibrium occurring as we're creating more and more and more products. What can start to happen is they can actually inhibit or slow down the catalyzing of reactions. So if we have an abundance of products, the rate of reaction can actually slow down as well and start to tail off, or form an equilibrium, start to plateau off. There's also something called cofactors. Now, cofactors are other substances outside of enzymes, substrates, and products. What cofactors can do, let's say these are molecules that can assist in enzyme activity. So they might do something like bring substrates down to the active site of the enzyme and just kind of help the process occur. So there's a number of different cofactors. They can be inorganic metal ions and amongst other different things. So there's cofactors that exist. We also see inhibitors being something which can influence enzyme activity. So we have non-reversible inhibitors. Actually, I'll just leave that as them. Non-reversible inhibitors. So these are inhibitors that affect the enzyme to the point where it is no longer able to do its job. So they can drastically break down the bonding or affect the active site, and then that enzyme is done. It is no longer any good. But we can also see reversible inhibitors. So reversible inhibitors can have an effect on the enzyme and stop it being able to do its job. But if they are, the enzyme is able to overcome this and still be used. It is not done forever. It is not ruined. So beneath that heading of reversible inhibitors, there are two forms or two types of reversible inhibitors that we can see. So I'll draw an enzyme here to demonstrate that. Let me try that again. Alright, that will do. So that's an enzyme, and this is going to be an example of a competitive reversible inhibitor, or just a competitive inhibitor will do. So what will occur here is with a competitive inhibitor, we have a substance, so this is our inhibitor here, which shares a similar shape to a substrate, which the enzyme wants to break down. But the inhibitor, so it could be a chemical or a different molecule, the inhibitor tries to bind to the active site because it shares a similar shape to the substrate and blocks it. So this means the substrate is unable to bind to an enzyme and is unable to be broken down. But if that inhibitor is gotten rid of or leaves, then that substrate is still going to have clear passage. So the enzyme can be used. It is not going to be ruined forever if the competitive inhibitor makes way again for the substrate. Now, the other type of inhibitor we see is a non-competitive inhibitor. And what this will do is this type of inhibitor tries to bind to a different location. So not on the active site, but they're going to bind to a different site on the enzyme. And what this is going to do is this is going to affect and change the shape of our active site because it's going to twist and bend the enzyme. So if this occurs, then our substrate is not going to be able to make its way to the active site and bind because the shape of it has been changed by the non-competitive inhibitor. So a lot of different factors that can influence enzyme activity. We've got reversible and non-reversible inhibitors. So under reversible inhibitors, we have competitive and non-competitive inhibitors. We also see cofactors, which can assist and influence the activity of enzymes. Substrate and product concentration and enzyme concentration are important, as well as temperature and pH in influencing the ability of an enzyme to work at its optimal rate.